like to talk about the last part of the chapter. The last part of the chapter can be understood by focusing on the diagram I have on the left. I have a circle O, and I have two chords that are of equal length. The chords are marked as AB and CD. By the way, we know that if chords are equal, they are equally distant from the center. We also know that they form equal arcs. So the arc that goes through here from A over to B, this arc right here, it's got to be equal to this arc right here. Since the chords are equal, the arcs are equal. But actually right now, we're looking at the fifth theorem. The fifth theorem says if the chords are equal, namely if AB, this chord right here, is equal to this chord right here, CD, then they are equally distant from the center. So in other words, then OF, from the center to F, this point right here, okay, is equal to from O to E. Now you can see this, for example, on page number 717 at the very bottom. If you're looking at that picture, given that FG is equal to JH, since they're equal chords, they're equally distant from the center, then LX equals LY. Okay, now that information is very powerful. And that means that, let's go back to our diagram I'm showing you here with A, B, and C and D. If OF is equal distance from the center as OE, then we can make a right triangle OFA, and OFA will work according to the Pythagorean theorem. OA squared equals AF squared and FO squared. In other words, OF squared, I'll write it down here for you. OF squared, that distance squared, plus AF squared is equal to the distance OA squared, and of course that is the radius. So the radius squared equals the sum of the parts of the triangle, and each of those parts is squared. I'd now like to talk about some of the problems you're going to do. Let's look at a few of the odd problems. You're going to do all of problems 1 through 23. You can start at any time, but I'll explain a few if you'd like to listen. Number 1, we have equal chords. RS is equal to ST. This is on page 718. Since the chords are equal, then their arcs are equal. Okay, so the arc ST is equal to the arc SR, but we also know that a central angle equals its arc. So if the angle is 93, the arc ST is 93. And that makes the arc SR the same. I'd like to jump on to problem number 5. Problem number 5. We have given that JK is 10. All right, since we have a right angle here, we know that JK is being split in half. QK, for example, is 5. And knowing that distance is 5 and the radius of the circle is 6, then PK is 6. So that will allow us to set up a right angle. PK squared, 6 squared, is QK squared, 5 squared plus QP squared, which will allow me to solve number 5. Number 7, we're given that we have equal chords, but equal chords make equal arcs. So what must the 105 equal? Number 11, equal arcs make equal chords. So what does 3x plus 5 equal? All right, on to number 16 and 17. Here we're given the radius is 14. So A to D is 14. CD is 22. Since we have a right angle there, CD is cut in half. ED is therefore 11. 11 squared plus EA squared is going to allow me to find, or can be used to find, the radius, which is 7 squared, or 14 squared, pardon. AD is 14. And once I know AE, I can subtract it from the radius to find EB. All right? So that's how you do 16 and 17. And one more for you, and that is problem number 23. Remember that chords equally distant from the center have the same length, so LM equals NP, but of course Q is a midpoint as R is, and we're given here that LM is 16, so NP must be 16, and RN, for example, must be 8. It's telling me that NP is 4x, so that's the same length as 16. We can solve for x. So your assignment is through problem number 23, 1 to 23.